We do it all the time, right? Click pay, book, transfer. We don't even think about it. But what happens if the app crashes right at that moment? There's this invisible safety net, this hidden guarantee that makes it all work. And today, we're going to pull back the curtain on it.
Okay, let's just start with a scenario that I'm sure gives all of us a little bit of anxiety. You know the feeling. You're buying something, you're transferring money, you hit that final button, and then nothing. The app crashes, the screen just freezes, and that sinking feeling hits your stomach. Did my money just disappear into the void?
This isn't some rare once-in-a-blue-moon problem. For the people who build these systems, it's a constant battle. Systems fail, networks drop, glitches happen all the time. So the big question is, how on earth do you build something we can trust on such a shaky foundation? Well, the answer is actually this really elegant and powerful idea called a transaction.
All right, so let's really dive into this, because this one core idea, it underpins pretty much every single digital thing you do that involves changing data. Think about it. A bank transfer, booking a flight, buying a coffee, all of it.
So here's the key. A transaction isn't just one single action. It's really a series of steps that are all bundled together. Like step 1, take money from my account, and step 2, put money in their account. The system treats that whole bundle as one single thing. It's all or nothing.
And I love this analogy that came up in our research. It's like a package deal. Think about it. You wouldn't accept a delivery if only half the stuff you ordered was in the box, right? No way. You want everything or you want nothing. And that is the fundamental promise of a digital transaction.
Now, this all-or-nothing promise is so incredibly important that it's actually guaranteed by 4 super strict rules. And together, they form this acronym that's, well, it's kind of famous in the world of computer science. ACID. ACID. Okay, first up, the A in ACID. That stands for atomicity. And it's just like it sounds. You know how an atom was once thought to be this indivisible little particle? Well, a transaction has to be indivisible too. It absolutely cannot be left half-finished.
So here's what that actually looks like. Let's say you're sending $100 to a friend. The system takes the money out of your account, but then, bam, the whole thing crashes before it can put the money in your friend's account. This is where atomicity becomes your hero. It kicks in and just cancels the whole operation. The system does what's called a rollback, and that $100 goes right back into your account, just as if you never even hit send. It's what keeps your money from just vanishing into some digital black hole.
All right, next up is C for consistency. And you can really think of this one as the rule keeper. It's like a bouncer at a club, but for your data. Its only job is to make sure every single transaction follows the rules of the system, no exceptions.
So for instance, a bank's database has a really simple, fundamental rule. Your account balance cannot go below 0. You can't spend money you don't have. Well, consistency is the property that enforces that. If you try to make a transaction that would break that rule, it just gets blocked. It won't even start. That's how the integrity of the whole system stays intact.
Okay, now we've got I for isolation. And this one is absolutely crucial for managing what could be total chaos. I'm talking about when thousands, maybe even millions of transactions are all trying to happen at the exact same time. So what isolation does is it basically puts each transaction into its own little protective bubble. This stops all sorts of weird problems, especially something called a race condition. And that's exactly what it sounds like. 2 people racing for the same thing, like trying to book the very last seat on a flight at the exact same microsecond. Isolation makes sure that these transactions don't trip over each other. It processes them as if they happened one after the other, nice and orderly, so only one person gets that ticket and the database doesn't get confused.
And that brings us to the last letter, D, for durability. Honestly, this is the ultimate guarantee. It's the system's promise that once a transaction is finished, it stays finished. Period. So when a transaction is fully complete, or committed, as the tech folks say, the results get written down in permanent ink, so to speak. So when you see that payment successful message pop up, that's not just a friendly notification. That is a solid gold promise that your data is safe and sound, even if the whole system crashes 1 second later. Power outage, server meltdown, doesn't matter. It's saved.
Okay, let's circle back for a second to isolation, because this is where things can get really messy if they go wrong. To really get why it's so important, we have to look at what happens when a system tries to handle a bunch of requests at once without that protective bubble.
So check this out. This is a classic problem called a lost update. Imagine two different customers, A and B, trying to buy the last of some popular item at the same time. Okay, so step 1. A's computer reads the stock level. It's 10. Step 2, B's computer reads the stock level. It's also 10. Now A buys one item, and their system calculates the new stock should be 9. At the same time, B buys two items, and their system calculates the new stock should be 8. Here's the problem. A's system saves its update, writing 9 to the database. But then B's system saves its update, writing 8, and completely overwriting what A just did. The final stock is wrong. The database says 8 are left, but we know 3 were sold, so there should only be 7. It's a total mess, and isolation is what prevents this exact scenario from ever happening.
Okay, so let's zoom out again. When you put all 4 of these rules together, atomicity, consistency, isolation, and durability, ACID, what you get is this incredibly strong system that really is the foundation of trust for our entire digital world.
I mean, these 4 principles, they are the invisible engine that makes everything reliable. They're the reason your money doesn't just get lost during a bank transfer. They're why an online store doesn't accidentally sell you an item it doesn't actually have. And they're why your data is still there even after a massive system crash. It's the hidden code that just makes our digital lives work.
So the next time you click Pay or Book or Send, just take a second to remember this powerful system of rules humming along quietly behind the scenes, just keeping everything from falling apart. These ACID properties are just one piece of this invisible architecture that builds trust into our world. And it really makes you wonder, doesn't it? What other silent, invisible systems are out there, quietly creating order out of what could be total chaos?